In 10.4, we're going to take a look at graphing polar equations. We're going to do it by plotting points, but we've got some kind of foundational ideas to take a look at first. Now, I don't confess to having done a lot of this or it being all that particularly useful, especially in the age of technology where you can graph all this, but let's go through the ideas. I think you'll understand. We have talked about symmetry before. We've talked about even and odd functions. So an even function is one like this. It's x squared. You could put in negative x and you'd get the same thing on the other side. So you put in negative x here, do you remember this? You get right back to x squared. That was symmetry with respect to the y-axis. We could also talk about symmetry with respect to the origin. That's what an even function was. We talked about that too. I won't go through all of it. But in a similar way, what we're going to do is we're going to look at symmetry tests here for polar equations. Now, it has some caveats. I'm not even sure why. They say these tests are not foolproof, and that boggles my mind. So I'm not sure why we're going to learn them if it's not foolproof. But here's the basic idea. There are three checks that may or may not prove symmetry in different respects. The first is this. We're going to check symmetry with respect to the line theta equals pi over 2, which is essentially the y-axis. So just like an even function, we're going to see if we can flip into quadrant 2 and get the same value. So the way we're going to check that is if we switch from r theta to negative r negative theta, just like here we switched in a negative x and we tested to see what happens. Well, here what we would do is we're going to do negative r and negative theta. Now, why would that work? Well, negative theta moves us down. So instead of going up, remember a negative angle will move us down, and negative r will move us to the other side. It goes backwards. So we're going to move into quadrant 2 and see if we get the exact same thing. That's our first check. The second is respect to the polar axis, but the x-axis. And what we're going to do here is see if we get the same thing. Oops, sorry. See if we get the same thing in quadrant 4 as we do in quadrant 1. And if that's the case, then we have symmetry with respect to that polar axis, that x-axis. Now the way we're going to do that is we're going to replace theta with negative theta. So we would normally go up and have theta. If we do negative theta, it'll move us down to quadrant 4, and we'll see if we would get the same thing. And lastly, we tested an odd function was one with symmetry related to the origin. Well, here we're going to call it symmetry related to the pole. It's the same thing. And what we're going to do is we're going to place r theta with negative r. We're just going to replace r with negative r, so we'd keep the same angle, but the negative r will move us into the third quadrant, and we'll see if we'd have the same thing. Okay, so let's take a look here. Something's wrong with this here. Yeah, so that's should say this. Okay, so here's what we're testing for symmetry. 2 sine of theta. We're going to do each of the different tests. So we're first seeing if we're symmetrical with respect to the y-axis, which is the line theta equals pi over 2 here. Now, even when I talk about these, I talk in coordinate plane because that's what's normal and standard for me here. But what we're doing is we're checking our first symmetry test. We're going to check what happens in quadrant 2. So in quadrant 2, we're going to replace negative r and negative theta into the equation and see if we get right back to where we started. Well, look what happens. I'm putting in negative r and a negative theta. Now remember how that works for a sine function is an odd function, so the negative just comes out front. We divide that negative across. We got right back to where we started. So we have passed the first test. In theory, anyway, this is symmetrical between the first and second quadrant as we flip over theta equals pi over 2. In other words, the y-axis. Okay, now let's try it again. We're going to check in quadrant 4. So we're basically checking with symmetry, and I'm just going to call it the x-axis from now on. This is what we're comfortable with. So we're checking for symmetry in terms of the x-axis. So the way we check that is we replace theta with negative theta. So that would be, so we're normally up here, negative theta would move us down to quadrant 4. Okay, now sine of negative theta, this is an odd function, so it moves it out front. And we don't get the same thing we started with. So this does not appear to be symmetrical with respect to the x-axis. Now how about in terms of the origin here, the pole? So in order to check that, what we're going to do is simply change r to be negative r. Now if you see what's going to happen here, plug in negative r, we do not get back to the same thing. This is not going to be the same thing, so we failed that one as well. So the only one we found symmetry is that we had symmetry in respect to the y-axis. Now the reason that happened is here's the graph. It's going to be a circle, and you see we have symmetry only across that y-axis. Okay, so let's take our tests and let's check them again for this function. So our first test, we're going to do r theta, and we're going to change it by moving it into quadrant 2. So negative r negative theta would accomplish that by going down and then back up. So going down with negative theta, back up with negative r gets us to quadrant 2. So let's see if this gets us the same thing. So we're putting in negative r and negative theta. Now, we've got negative r. Cosine of negative theta, since it's an even function, is going to stay the same. And you see if we solve this, so I've just divided the negative across. This is not what we started with, so I've failed the first test. So we don't appear to be symmetrical with respect to the y-axis. Now let's check with respect to x. And there what we do is we change theta into negative theta. Okay, so if I've got r negative 2 cosine of negative theta, this is going to work because this is an even function. That negative inside of there on the angle doesn't do anything. And so I get right back to where I started, so we've passed this. So we think we have some symmetry with respect to the x-axis. And then lastly, let's move in quadrant 3. So we want to see if we have symmetry with respect to the origin. And oh no, I'm wrong on that, sorry. We're going to change r into negative r. So the angle stays the same, and negative r is going to send us into quadrant 3. So okay, so if I divide this, I get r as 2 cosine of theta, but that's not what we started with. So I failed this one as well. So we have symmetry, it appears to be, with only with respect to the x-axis. Now, it's actually easier, it would be much easier if we converted this into out of polar and into Cartesian rectangular. We could graph this much easier and it'd be much simpler. I think that would actually be the way to go, but they're asking us to keep it here. But I'm pretty sure that if we flip this over, what we're going to get here is a circle that's in right here. So it's going to be a circle on the right side of the y-axis, and what that shows us is we should have symmetry with respect to the x-axis, but that's all we have. So again, we could take our principles from the last lesson and we could switch this into x and y's, make it Cartesian rectangular, and we would have a much easier time graphing it. But anyway, they want us to stick with the polar here and see. So okay, so what we're going to do here is we're going to begin to plot points to see how to graph these things. Now, before we do that, they've given us some tips. That what we want to do, what would be helpful, not essential, but what we might want to do is we're going to find where the values are 0, and we're also going to find maximum values. So let me explain this to you. So the 0 here is going to be literally when theta equals 0. So that's going to be where do we hit the x-axis. Now, in order to do that, we're going to do that just the same way we did when we were solving an equation and wanted to know the x-intercepts. What we would do is we would say y is 0. So we're going to do the same thing. So if my equation is r equals 2 sine of theta, I want to know when theta solve for theta. That happens when r is 0. So let's try it. So just like I would set y equal to 0 and solve for x, I'm setting r equals 0 and I'm solving for theta. Now we do this, you see we're solving this, straightforward. Now we just need to inverse this. When does sine of theta equal 0? Well, it equals 0. Now they're getting fancy with us here, but it is 0 here and here. And you could just keep spinning around and around. But the point is, at 0 and pi is when this is equal to 0. So we now know these points, these intercept points. So we know when theta is equal to 0 and when theta is equal to pi, we will have what we'll call intercepts here. Okay, now let's plug those in and see what happens. Well, if if I put 0 into this original equation, so we're going to find r. Let's get some actual points here. So 2 sine of 0, oops, I'm sorry, that should be a 0, not a theta. 2 sine of 0, well, we know that's 0, so 2 times 0 is 0, so we get r is 0. And the same thing would happen with pi. But so here's what we've got. The 0 for this is literally 0, 0, which means we have a point right there at the origin, at the pole in this case. Okay, so we have the 0. Let's talk about the maximum. What we're trying to do here is find the largest value that this function ever takes, and that's going to help us plot a key point as well. Well, wouldn't that happen? So sine is a wave. If you think of it linearly, it's a wave. So the largest it ever gets is when it's equal to 1. So let's look at this equation. The largest it's ever going to get is when this value of sine is equal to pi over 2. That's when it's positive 1. So I'm just thinking through the logic. No, sine is largest at pi over 2. If I plug that into the equation, I get r is 2. Do you see what I'm saying here? I know this is maximum value is 1. So if that's 1 at pi over 2, r is 2. So I have the point pi over 2, 2. Must be the largest point. So we have our little circles here. We have these 2 points at the origin and here. Now, what we could literally do, I don't know if I showed this, I didn't. What we could literally do is just make a chart, just like we always did, and we could find different values of r and theta, and go through here to plot some additional points. So when r is 1, what do we get? Well, we're going to find there's 2 possibilities here. We could find pi over 6, or 5 pi over 6. Actually, we should go the other way. Yeah, I should be doing this the other way. It should be thought of like this because r is going to represent like y would be. So we would pick different values of theta. So we say, what happens at pi over 6? Well, this equation is going to yield 1. What happens at pi over 3? This equation is going to yield 1.73. And so we had these points here. We have this one and this one. We could plot some additional points our way around the equation, or around the polar axis, and we'd get the circle. Again, switching to rectangular would be much, much easier, but nonetheless, it can be done. Okay, so they want us to do one more here, and they're going to ask us, first of all, let's do our test for symmetry, and then we're going to find the zeros and maximum values. So let's do that. Is this the same equation we did earlier? I'm not sure. So let's do our test. So first of all, let's check whether or not, with respect to the y-axis, this is symmetrical. At least we hope it's symmetrical. So this moves us into quadrant 3. Negative theta moves us down, negative r moves us back. So in quadrant 3, do we get the same thing we had before? Okay, so remember, the cosine of the negative angle doesn't change anything. Do you see this is not going to be the same? This is going to fail this test. We do not appear to be symmetrical in quadrant 3. Okay, let's try quadrant 2. So quadrant 2, we're changing theta into, no, I'm sorry. We're checking with symmetry with respect to the x-axis. So we're going from theta to negative theta. We have this angle, and now it's moving us down. So we've got theta to negative theta. We're checking with respect to the x-axis. So I'm going to take 3 cosine and make it negative theta. And yeah, this is the same thing, because negative theta is the same thing. Okay, so I get the same thing. So we pass this test. All right, let's do one more. Let's check with respect to the origin, and that's where you change r into negative r. So the angle stays the same, but negative r would now send you down over here. Let's see if we get the same thing. So this is going to be negative r equals 3 cosine of theta, and I hope you can see this will not be. This is going to be negative 3. That is not going to pass. So we failed that one as well. So the only one we think we have symmetry with respect to is at the x-axis again. Again, I think I know this is a circle. This is a circle over here, so that's why. But let's go ahead. Let's find our zeros. And so, just like we would do to find the value when x is 0 or when y is 0. So if we were doing this to solve for the x-intercepts, we would make y is 0. So to find the theta intercept, we're making r 0. So we've got 3 cosine of theta equals 0. So cosine of theta equals 0 again, because you divide the 3 across. So when is cosine of theta, oh, my graph is wrong then. Cosine of theta equal to 0. Well, cosine of theta is 0 at pi over 2. And we'll think of it like negative pi over 2. Okay? All right, now let's plot these points here. So if I put in pi over 2, I get 0. So I guess it'll just be this. Pi over 2, 0. Negative pi over 2, 0. All right, let me double check that I'm thinking this right. Cosine of theta. Yeah, that's right. Okay, so here's our zeros. Pi over 2, 0, and negative pi over 2, 0. Now, let's find the maximum value. So cosine's maximum value, because it's also a wave, cosine is maximized at the value of 1. So when cosine of theta equals 0, we get 1. And when cosine of theta, or I guess I should say, if we put theta equals 0 in, we get 1. If we put theta equals pi in, we get negative 1. So that we don't want that one. We want this one. So cosine of 0, cosine of 0, oh my gosh, I keep doing the same thing. So r equals 3 cosine of 0 would be our maximum value. So our maximum value for r is going to be 3. So at the point 0, 3, we get our maximum value. Oh, I know why I'm struggling. I'm writing these the other way around. Sorry. R theta. R theta. Sorry, remember in polar it's r theta, not the other way around. Okay. So I've solved for 0 here, and I found the values, pi over 2, negative pi over 2. Those are like my intercepts. Now, how about the maximum value? The maximum value here would occur when cosine is 0. That makes 1. So when I have r, so that gives me an r of 3. So here are the points that I have so far. I have the point 3. So my circles here. So I have this point right here, 3, 0. And what else do I have? I also have 0 pi over 2. And I have 0 negative pi over 2. So actually that's the same point. So there's the point right there. Okay, so those two make the same exact point. I've got here and here. Now, if we pick some points, we'd go through here and we'd pick some thetas and we'd find what r's we get out. What we're going to find here is that we're going to work our way around this circle here, and we're going to get a circle like this. So let me just show one or two. So suppose we picked pi over 6. So what would happen at 30? So pi over 6 going into this equation creates, let me just do one. So that's a 60. Oh, you know what? Let's pick pi. Yep, let's pick pi over 3 because you're going to get a nicer number. If you put pi over 3 in here for theta, you're going to get 1/2. So this is going to be 3/2 or 1.5. Okay, so at pi over 3, which is about 60, we're going to get about 1.5, which would be right about here. My circle's terrible. We could do the same thing with negative pi over 3. We're going to get 1.5. So we could continue plotting points, and what we're going to do is we're going to work our way around and create this circle right here. Now again, this would have been much easier to graph if we just converted it. Using our skills from the last time, we would have seen it's a circle centered over here, but that's what this section's about. So, okay, now that's not the easiest thing ever. I hope it made some sense.